In this Java tutorial, we're going to download and install the necessary tools to build Java applications. So open up your browser and search for JDK download. JDK is short for Java Development Kit, and it's basically a software development environment for building Java applications. It has a compiler, it has a bunch of code that we can reuse, it has a Java runtime environment, and a bunch of other stuff. So over here, you can see this page on oracle.com, Java SE, which is short for Java Standard Edition. Click on this. Now over here, click on this icon. Now on this page, you can see Java Development Kit for various platforms like Linux, macOS, and Windows. Here I'm on a Mac, so I'm going to download this DMG file over here. Now before we do this, first we need to accept the license agreement. All right, now let's download the DMG. When we open this, we're going to see this package. Let's double click this. And here we see this installation wizard. It's super easy. Just click continue and install. You have to enter your computer's password and then, all right, done. Beautiful. So we can move this to trash. Now, the next piece of software we need is a code editor. There are so many code editors for building Java applications. The popular ones are NetBeans, Eclipse, and IntelliJ. In this Java course, I'm going to use IntelliJ, but if you have a favorite editor, feel free to use that to take this course. That's perfectly fine. So let's search for IntelliJ download. All right, you can see download IntelliJ IDEA. Click on this link. Over here, download the community edition, which is absolutely free, and it's more than enough for this course. So download. All right, now let's drag and drop this onto the applications folder. Beautiful. All right, we've installed all the necessary tools to build Java applications. So next, we're going to look at the anatomy of a Java program. In this Java tutorial, we're going to look at the anatomy of Java programs. The smallest building block in Java programs are functions. A function is a block of code that performs a task. As a metaphor, think of the buttons on the remote control of your TV. Each button performs a task. Functions in programming languages are exactly the same. For example, we can have a function for sending emails to people. We can have a function for converting someone's weight in pounds to kilograms. We can have a function for validating users' input and so on. Now let's see how we can code a function in Java. We start by specifying the return type of that function. Some functions return a value like a number, a date time, and so on. Other functions don't return anything. So the return type of these functions is void. Void is a reserved keyword in Java, and that's why I've coded that in blue here. Now, after the return type, we have the name of our function. So here we should give our function a proper descriptive name, like send email. This name clearly identifies the purpose of this function, okay? Now, after the name, we have a pair of parentheses, and inside this parentheses, we add the parameters for this function. We use these parameters to pass values to our function. For example, our send email function should have parameters like who is the receiver, what is the subject of this email, what is the content of this email, and so on. Now, in this tutorial, we're not going to worry about parameters. We'll look at them in the future. Now, after the parentheses, we add a pair of curly braces, and inside these braces, we write the actual Java code. Now, one thing I want you to pay attention to here is that in Java, we put the left brace on the same line where we define our function. In other programming languages like C#, it's more conventional to put the left brace on a new line, but we don't do that in Java. So we put the left brace on the same line where we define our function. Now, every Java program should have at least one function, and that function is called main. So main is the entry point to our programs. Whenever we execute a Java program, the main function gets called, and the code inside this function gets executed, okay? Now, these functions don't exist on their own. They should always belong to a class. So a class is a container for one or more related functions. Basically, we use these classes to organize our code, just like how products are organized in a supermarket. In a supermarket, we have various sections like vegetables, fruits, cleaning products, and so on. Each section contains related products. By the same token, a class in Java contains related functions. Now, every Java program should have at least one class that contains the main function. Can you guess the name of that class? It's main. So this is how we define a class in Java. We start with a class keyword, then we give our class a proper descriptive name, and then we add a pair of curly braces. Now the functions that we define in between these curly braces belong to this class. And more accurately, we refer to them as methods. So a method is a function that is part of a class. In some programming languages like Python, we can have a function that exists outside of a class. so we call it a function. But when a function belongs to a class, we refer to it as a method of that class, okay? Now, in Java, all these classes and methods should have an access modifier. An access modifier is a special keyword that determines if other classes and methods in this program can access these classes and methods. We have various access modifiers like public, private, and so on. Now, most of the time we use the public access modifier, so we put that in front of our class and method declarations. So this is the basic structure of a Java program. At a minimum, we have a main class, and inside this main class, we have the main method. Now, you might be curious why we have a capital M in the name of this class. Because in Java, we use different conventions for naming our classes and our methods. To name our classes, we use the Pascal naming convention, and that basically means the first letter of every word should be uppercase. In contrast, to name our methods, we use the camel naming convention, and that means the first letter of every word should be uppercase except the first word. So that is why we have a capital M in the name of this class. All right, now that you understand the anatomy of a Java program, let's create a new Java project and see all these building blocks in action. In this Java tutorial, you're going to learn how to write and execute your first Java program. So let's open IntelliJ IDEA. Here on the home screen, let's create a new project. All right, on the left side, select Java and make sure Project SDK is not blank. So earlier we downloaded JDK or Java Development Kit version 12. That is why JDK version 12 is selected here. If you don't see that, make sure to select it from this drop-down list. All right, now let's click on Next. On this page, select Create Project from Template. So we're going to create a command line application, which is an application that we can run from the command line. It doesn't have a graphical user interface or a GUI. Now, I know a command line application is not as exciting as an application with a graphical user interface like a mobile app or a desktop app, but trust me, building an application with a graphical user interface is very complicated. So for now, we're just going to build command line applications to learn Java properly. Once you learn Java properly, then you can learn about building desktop or mobile applications with Java. All right, now let's click on Next. On this page, we have to give our project a name. Let's call it Hello World. Now over here, you can see the location of this project. So it's inside the IDEA projects folder. Now right below that, you can see the base package, which is set to com.codewithmosh on my machine. On your machine, it's probably going to be com.package. What is this? Well, earlier we talked about classes and methods. I told you that a class is a container for related methods. So we use classes to organize our code. By the same token, we have a concept called package, and we use a package to group related classes. So as our applications grow, we're going to end up with hundreds or even thousands of classes. So we should properly organize these classes into packages. Now, by convention, the base package for a Java project is the domain name of your company in reverse. So my website is codewithmosh.com. That is why I'm going to set the base package for this project to com.codewithmosh. Now, it doesn't mean that you should have an actual domain registered on the internet. This is just a way to create a namespace for our classes. So now every class that we create in this project will belong to this package. We're going to talk about packages in more detail in the future. So for now, just type a base package for your project. It can become your name or whatever. It doesn't really matter. All right, now let's go forward. All right, here's our first Java project. Now this code editor might look a little bit intimidating at first, but trust me, it's really easy and you're going to learn about it throughout this course. On the left side, we have the project panel where we can see all the folders and files in our project. For example, on the top, we have the Hello World project. Inside this project, we have the source folder where we have the source code of our project. Now in this folder, we have another folder that is com.codewithmosh. That is the name of our base package. And in this package, we have this class, main. So you can see this main file opened on the right side here. Now look at the name of this file. It's main.java. So all Java files should have the Java extension, okay? Now, let's collapse the project panel by clicking on this icon. That is better. So see what we have here. On top of this file, we have the package statement, and this is used to specify what package this class belongs to. So the main class that we have here belongs to this package. Now, this package statement is terminated by semicolon. So in Java, wherever we have a statement, we should terminate that statement with a semicolon. This is exactly like C# or C++. Now, below this package statement, we have our main class, exactly like what you saw in the previous tutorial. So we have public class main with a pair of curly braces. Inside this class, we have our main method. So it's a public method, which means it's accessible from other parts of this program. It's static. We haven't talked about static methods yet. We'll talk about them in the future. For now, just remember that the main method in your program should always be static. The return type of this method is void, which means this method is not going to return a value. And here in parentheses, we have one parameter for this function. We can use these parameters to pass values to our program. Again, we'll look at this in the future. Now, right after this parenthesis, you can see the left brace, and this is where we write the code in this method. Now, by default, we have this line prefixed with 2 slashes. This indicates a comment. We use these comments to explain our code to other people, so these comments don't get executed. Now, let's remove this comment and write a bit of code to print something on the terminal. So here we're going to use the system class in Java. So capital S, system. Here in this tooltip, you can see the system class is defined in this package, java.lang or language. Also, look at this icon on the left side. This indicates a class. Now, inside this class, we have various members. We can use the dot operator to see the members defined in the system class. Now, the member that we're going to access is out. Look at the icon of this member. It's F, which is short for field. We're going to talk about fields in the future when we talk about classes and object-oriented programming. Now, what is interesting here is the type of this field, and you can see that on the right side. That is print stream. So print stream is another class that is defined in Java. So once again, we use the dot operator to look at the methods or members defined in the print stream class. The method we're going to use is println, which is short for line. Look at the icon for this method. So M indicates a method. Now, we press enter, and IntelliJ automatically adds these parentheses as well as a semicolon. So now with the code on line 6, we're calling or executing the print line method. Earlier I told you that inside this parentheses, we can pass values to our methods. Here we want to print the hello world message on the terminal. So let's type double quotes, and inside these quotes write hello world. So hello world is textual data. In Java, whenever we deal with textual data, we should always surround them with double quotes. Now we say we have a string. So a string is a sequence of characters. All right, so we're done with our first program. Now to execute this, we can click on this icon on the toolbar. Look at the shortcut. On Mac, it's Control and R. I always prefer to use shortcuts because they're faster. So Control and R. Now, IntelliJ is building our application, and we can see the result in this little terminal window. So here's our hello world message. So that was our first Java program. Next, I'm going to explain how Java code gets executed under the hood. Involved here, compilation and execution. In the compilation step, IntelliJ uses the Java compiler to compile our code into a different format called Java bytecode. This Java compiler comes with the Java development kit that we downloaded at the beginning of the course. Let me show you. So here we can right-click on this main.java, and in this context menu, we have an item called Open in Terminal. It's down below. Unfortunately, it's not visible in my recording window. It's called Open in Terminal on Mac and probably Open in Command Prompt on Windows. So let's open that. We get this terminal window or command prompt on Windows. Here we're currently inside of this folder, Code with Mosh. That is where we have our main.java file. Now we can invoke the Java compiler like this, Java C, and pass the name of our Java file as an argument. So main.java. If you're on Mac or Linux, make sure to spell this with a capital M because these operating systems are case sensitive. So enter. Now let's look at the content of this folder. On Mac or Linux, we can type ls. On Windows, we type dir. So let's take a look. In this folder now we have a new file, main.class. This is the bytecode representation of this Java file. Now, when we use IntelliJ to run our Java program, this class file gets stored somewhere else. Let me show you. So back to the project panel. Here in our project, we have this source folder where we have our source code, and we have this out folder where we have the result of the compilation. So inside this folder, we have production. Inside this, we have hello world, the same name as our project. Inside hello world, we have com, which is the name of our top level package. Inside this package, we have a sub package that is code with Mosh. And here we have our main.class file. So this was the compilation step. Now, this Java bytecode that we have in this file is platform independent. And that means it can run on Windows, Mac, Linux, or any operating systems that has a Java runtime environment. If you go to java.com/download, we can download Java, or more accurately, Java runtime environment for various operating systems. This Java runtime environment has a software component called Java Virtual Machine, or JVM. This JVM takes our Java bytecode and translates it to the native code for the underlying operating system. So if you're on a Windows machine, this Java Virtual Machine converts our Java bytecode into the native code that Windows can understand. This architecture is the reason why Java applications are portable or platform independent. We can write a Java program on a Windows machine and execute it on Linux, Mac, or any other operating systems that have a Java runtime environment. C# and Python also have the same architecture. That's why they're platform independent as well. Now let me show you how to invoke this Java virtual machine to run a Java program. So back to this terminal window, let me expand this. Currently we are inside of this folder code with Mosh, and in this folder we have this class file. Now let's go one level up. So cd ... and one more time. So now we are inside the source folder. We can invoke Java virtual machine like this. We type Java, and then we type the full path to our main class file. What do I mean by that? Well, earlier we defined this package com.codewithmosh, and this class, the main class, is part of this package. So the full path to this class is com.codewithmosh.main. Make sure to use a capital M here because this is case sensitive. Now when we press enter, Java will look at this folder, com. Inside this folder, it will look at this other folder, codewithmosh, and then it will find main.class in that folder. It will load the bytecode and convert it to the native code for the operating system we are using. So take a look. So it executed our program, hello world. Beautiful. When we run a program using IntelliJ, all these steps are hidden from us. We don't see the compilation or execution steps. So you have seen Java in action. Now let me tell you 5 interesting facts about Java. Java was developed by James Gosling in 1995 at Sun Microsystems, which was later acquired by Oracle in 2010. It was originally called Oak after an oak tree that stood outside Gosling's office. Later it was renamed to Green and was finally renamed to Java, inspired by Java Coffee. That's why its logo looks like this. We have 4 editions of Java for building different kinds of applications. We have Java Standard Edition. This is the core Java platform, which is what we're using in this course. It contains all of the libraries that every Java developer must learn. We have Java Enterprise Edition, which is used for building very large-scale and distributed systems. It's built on top of Java Standard Edition and provides additional libraries for building fault-tolerant, distributed, multi-tier software. We have Java Micro Edition, which is a subset of Java Standard Edition designed for mobile devices. So it has libraries specific to mobile devices. And finally, we have Java Card, which is used in smart cards. The latest version of Java is Java Standard Edition 12, which was released just a few months ago in March 2019. Java has close to 9 million developers worldwide. Currently, about 3 billion mobile phones run Java, as well as 120 million TV sets and every Blu-ray player. According to Indeed.com, the average salary of a Java developer is just over $100,000 per year in the US. So as you can see, Java is everywhere, which means more opportunities for you to get hired as a professional programmer. This course is the first part of my complete 4-part Java series. Each part is about 3 to 4 hours long, so you can easily complete it in a day or 2. In the first part, which is what you're watching, you're going to learn the fundamentals of programming with Java. In the next section, you'll learn about the type system in Java. You will learn how to work with various types, such as numbers, strings, booleans, and arrays. By the end of this section, you will build a mortgage calculator as your first Java project. We'll be improving this calculator bit by bit throughout this course. Next, you will learn about control flow statements that are used to build algorithms. We'll be talking about various types of conditional statements and loops. Later in this section, we'll add data validation to our mortgage calculator to force the user to enter valid values. At this point, you'll be able to build basic algorithms, and that's great. But being a good programmer requires knowing how to write good code, code that is clean and expressive. That's what separates an outstanding programmer from an average programmer. So in the following section, we'll talk about clean coding. I will show you various techniques that professional programmers use to make their code clean and maintainable. And finally, in the last section, you will learn how to find and fix errors in your Java programs, as well as how to package them for deployment so others can use them. So the materials in the first part will give you a solid foundation on how to start programming in Java. In the second part, we'll talk about object-oriented programming, which is a style of programming used in most, if not all, Java applications. Whether you want to use Java to build web, mobile, or desktop applications, you need to understand object-oriented programming well, because otherwise you're going to constantly hit obstacles. In the third part, we're going to talk about core Java APIs or application programming interfaces. You will learn about many of the useful classes in the standard Java library. And finally, in the last part, we'll be looking at the advanced features in Java, such as streams, threads, database programming, and so on. So I hope you're going to join me on this journey and master Java, the most popular programming language behind millions of apps and websites.